So, hello everyone, and maybe good evening at some locations, and welcome to the new edition of the Out of the Box Developer Podcast. And I'm very happy here today because today we have got a very special guest. But before he appears, I would like to say hello to Luis first. Hello, Luis. How are you
Hello.
doing?
Hello, I'm fine. And you, Tila, how are you doing?
I'm fine. Yes, I'm very excited for today.
Yeah, so am I. So hello, everyone. Today we have a very special guest. He's the creator of a conference, a big conference, and a very good newsletter. So I'm really excited to talk to him with him today. And I hope you enjoyed this conversation.
Yes. And hello to Hugo as well.
Hey,
Hi.
Sheila. Hello, everyone. I'm super excited and looking forward to this session. Today, we are bringing a big celebrity. So, yeah, have a lot to ask about.
And hello, Thiago. How are you?
Hello, Sheila. Hello, everyone from the chat. Yes, I'm also very excited for this session. We have an amazing guest, and it will be an amazing session. I'm sure for that.
And now, Igor, how are you?
Hi, Chilla. Hi, everyone. Hi, everyone that is watching us. Today we have a great session, a very special guest here with us, a true specialist. Will be great to hear from someone like him and have our questions answered, and also your questions. Send them in the chat so we can ask him about it. Looking forward for it.
Yes, sure. So, let's have it. Let's have him here on the stage. So, hello and welcome, Heinz Kabutz, Dr. Heinz Kabutz, Kabutz, Java champion, author of the very famous newsletter, and you are also a specialist in many topics, mainly in concurrency and performance topics. So you selected the hardcore topics of Java for you, right, Heinz? Oh,
Yeah, we can't hear you.
we can't hear you.
Your micro.
Well, just a little bug, guys. But he's a specialist. We'll be
Sort it
working
out.
on that.
Don't worry.
Oh.
Now we can hear you.
Now I can hear me.
Yes.
Not from here.
The mic was in the other.
Let me just switch microphones quickly. I'm going to change microphones quickly.
No worries.
Just whilst we run.
This is a live show.
Yeah, of
this
course.
Is the magic of the live show.
Check this out. I'll disappear for a second. Right, now I just have to fix this. This is now the... this one should be the right one. Testing 1, 2.
Okay, sorry.
All right, good.
It's mute again.
Mute again. Testing.
Now we can
Now
hear
it's
you.
okay, yes.
Now you can hear me.
Now
Yes.
we can hear
Yes,
this
sure.
microphone you just put.
And is it a good microphone?
Yeah, we can hear you pretty well.
If I tap there, does it tap?
Yes.
Yeah.
Yes.
Okay,
That's the
good.
right one.
That's the right microphone.
That's the right
So
one.
you've really put me in the spot here, because it's like, wow, after that introduction, I just want to leave. It's like pressure. But I want to start with something completely different, because you're carrying on about special. And in English, when you say somebody is special, well, it has other connotations as well, besides being a Java specialist. And when I was in school, when I was actually in preschool, let's just say I was quite special. And the poor nursery teacher didn't know what to do with me. Basically, whenever she said, okay, children, go play outside, my friend and I would go sit underneath the table and play Lego. And then whenever she said, okay, enough outside, come play inside, then we would go outside and play outside. We'd always do the complete opposite to what the teacher would say. And then I remember the one time we had this chain at home, and I took the chain. I was 4, right? I took the chain to the kindergarten. It was like a chain like this long. It wasn't very long, but it's like a chain. And I had this really great plan, and I said to the teacher, can you put your hands behind your back? And she's like, why? I said, well, let's just do it, And I carried on and on until eventually she did it. And I tried to chain her up, but I didn't think of how do I lock her up. So I just wanted to chain her up so that she would leave us in peace to do whatever we wanted to do. So this was my kindergarten time, my preschool. And and the teachers decided quite early that I'm definitely special. They wanted to send me to a special school for slow children, and they basically my mother didn't want to do that, so they said no, he's going to go to regular school, and so that was quite a fun way of growing up, to go to start off like that, really slow. Like just getting dressed took me hours and hours just to get dressed. So I really was very slow, and I was rather odd when I was small. And I think a lot of programmers can relate to that. We have our unconference here on Crete, and I would say about 99% of the people are on the spectrum, and those who are not, they just don't realize it yet. And it's just been it's a really fun conference.
Yes, it is. I can confirm it.
Shilla was there too. And maybe Shilla's one of them 1%, but I tell you, it's really funny because we're so different, the programmers. We once did a conference here in Chania on Crete. I live on the island of Crete now, and it was like a programming conference, and we sort of just took over this one coffee shop downtown, and because nothing happens in winter, we had 2 television crews at the event to film what's going on, and a bunch of speakers, and just all these geeks, just geeks and geeks. I call it a gaggle of geeks. We're a gaggle of geeks, and eventually they told us, please don't come back. Normal people, neurotypical people don't really like having us around. We're very odd people.
Okay.
Right. So should we start?
Yes. So in the meantime, there are a lot of people here. So I just show a few messages from the chat, from the live chat. So Andres is here with us.
Oh, Andres.
Yes, he's very often here.
Nice.
So he is in Lima, Peru right now, and he could join us. He would like to join J-Crate.
Yeah, we don't take people from Peru. Sorry, man.
We will need to travel to Crete.
Yes.
It's so far. It's really hard to get to from South America. We've had a few. We've had about 2 or 3 people from South America come. Bruno Souza came, but it took a lot of coaxing to get him.
Yes, he's also here.
Hey, Bruno.
Yes. And then there is another one. Life, universe, everything else in Java.
Even on topic of that question, Heinz, I could notice that you are a great storyteller. You tell stories from your life that are really involving. Do you believe that quality or that ability helps you to communicate with your audience, and even when you're talking about technology stacks?
I've been writing my newsletter for 25 years. November the 30th, I think, is 25 years. And the thing that people always come back to me is the fact that they love the stories. They love stories. People love stories because we're humans, and humans love stories. So yes, it's, for me that's like it's really, really important. And I actually got this idea not from the programming world. There was a guy who used to write a business newsletter called Pete's Weekly, Peter Carruthers. He doesn't really write anymore, but he used to write, every week in newsletter. And he had that style. Another guy also. So I sort of took from lots of different areas. I took from a guy who writes a business newsletter. I took the idea from a guy who wrote a joke newsletter. And this was a guy who used to be called Clean Laughs, LAFFS. It doesn't exist anymore. You can find the archives. And this Clean Laughs, he always had like a section before, and then after that, he had the jokes. And the section before was usually funnier than the actual jokes afterwards. So it's a style which I've started, and it works well. The only problem is, like, I'm famous for doing that. So if you do that, they're going to say, "Oh, he's just like Heinz." It's like if I, for example, take the Greek flag or the South African flag and I walk around carrying the South African flag, they're going to go, "Oh, it's just like Bruno." If I take off my shoes and I do my talk without shoes, they're going to say, "Oh, it's just like Venkat." So you really need to discover your personal trademark, your personal style, and use that. But I was talking to my wife just a few minutes before coming on, and we were actually talking about Bruno Souza. And the thing which makes Bruno special isn't what he does, because anybody can do what he does. What makes him special is who he is. His personality is so warm, he's so kind, he's always doing nice things for people. And that's what makes him special. So very often what people do is they try and copy what other people are doing, but you need to copy who they are, or better, get inspired by who they are and use that for yourself.
Mm-hmm.
Yeah, that's his own. That's Bruno. He's unique. It's like you're unique. You can get inspiration, get some characteristics, but you have to develop your own characteristics so
100%.
people recognize you. Oh, this is Bruno, this is Heinz, this is Igor, this is Thiago, this is Hugo. Each one is unique.
Yeah.
Great.
Mm-hmm.
You have
Thanks
to
for
develop
bringing
that
it.
style.
Amazing. Thank you, Heinz.
Pleasure.
And if we are talking about your newsletter, Heinz, that it has been around for more than 24 years. It makes a lot of effort. Or how can you keep that consistency that you are writing that newsletter every month?
Okay, so it helps to be a bit on the thrifty side, and for me, the way I see it is I'm paying for my newsletter service monthly. So if I don't write it, then I'm like paying for nothing. I know that doesn't really make sense, but like you get, it's like if you join a gym and you sort of, you want to now go to the gym, but now you're paying every month, and you don't want to go to the gym, and then eventually you go because you don't want to pay without going, and it's sort of you trick yourself into doing it. And that's actually like the motivation many months where I say I just don't have the energy. I don't want to do it. And then I say, right, let me just do this thing. And sometimes I write them very quickly, and other times it takes me days and days of research to write them. So it really depends. And the funny thing is, I never know which one's going to be good or which one people are going to like. Like the one which I'll spend 3 days, 4 days, 5 days researching and writing will be like it'll go down like a lead balloon. You know, won't work well at all. No comment, nobody likes it. And then other stuff which I just like, let's write this stupid thing, got to get this done. I've got another half an hour to finish this. That's like, it's like rave reviews. Oh, that's awesome! People retweet it and they share it with their friends and they get comments and like, oh, that's amazing. So the amount of effort you put in is not always necessarily connected to your popularity of it.
Okay. Yes. And also the name of the newsletter is not it's very special because you are saying Java specialists newsletter. And then you explained me a couple of weeks ago what it means. So you are writing for Java specialists who are already advanced in Java. So you are not writing for beginners.
Correct.
But because you are writing about advanced topics that not everyone can understand.
Yeah, more than half. I actually looked at this yesterday or the day before. More than half of Java champions are on my list.
Oh, that's huge.
It's huge. It's huge. So, or at some point were on my list. Maybe they're not on anymore because, the people do unsubscribe at some point, or they leave where they are and the email bounces. But at some point, more than half in total have been on my list. So that's a massive number. It's really a massive number of people who've been on there. And yeah, so it's and what Silla says is my target audience is the Java specialist. So if you're working with Java and you're like quite advanced already, this is my target audience. If somebody comes on there and say, "Hey, I just went on a 3-week course of Java, now I'm on your list," I'm going like, no. And you get some people who are always trying to give you advice on how to do your thing, do your newsletter better. It's like, I must just say something else, right? So I've given over 200 talks at conferences over the years. And what I'll sometimes do is I'll if I see that one of my colleagues is in the audience, like Bruno or Morris Naftalin or Kirk Pepperdine, or one of my friends who have also given, or Josh Long, they've also given, loads and loads of talks. What I'll do is afterwards I'll say, please give me some honest feedback how I can improve my talk. And that's going to be very useful to me to get the feedback from a speaker, because I might say, when you started, you need to get their attention more, or people started getting bored at about 20 minutes, or they'll notice stuff that others won't notice. But I'm not going to listen to. I'm going to try to not pay attention to like the general population's opinion of my talk, because they are sitting there as an audience, and I'm not an entertainer. I'm not there to entertain. My talks are not very funny. I don't have lots of different funny pictures and memes and stuff. Others do that, and they do that well. But for me, it's more telling a story, but also teaching something at the same time. So it's more teacher with, I want people to come out of it having learned something rather than just, be entertained and then not remember a word of what I said.
Heinz, how did you decide to talk to specialists? Was it something natural because you like to study and talk about advanced things?
So, I started this a long time ago, right? Java was still very new. Java was only 5 years old when I started the newsletter. But the reason I picked Java was because that's what I was working with. I started teaching Java the year before to corporates. So it was all very new. It was Java 1.1 basically, 1.2, something like that. But the reason I chose Java is that it's what I knew, and I thought that if I use that, I'm going to be able to write stuff about it. And also, the other thing is I used to do a lot of traveling from South Africa to Germany, South Africa to England, South Africa to France. And then I spent a lot of time at airports, and I would sit there, and people would always tell me you should write a book about Java because because I taught Bruce Eccles' hands-on Java course. I knew Java very well at that time. That Java 1.1 and 1.2, 1.3, I knew it very, very well, and so they wanted me to write a book, and I couldn't be bothered. It's too much work. But I did want to write topics, and so I wrote all these topics down when I was sitting in Frankfurt Airport, waiting for my flight. And then I took those topics and I started writing newsletters from that. And I tell you something, that writing a newsletter is terrifying because you send it out there and you've got no idea what feedback you're going to get. So you send it out there and you get like 10 responses saying, "Oh, that was awesome, great idea. I really learned a lot. Thank you so much." And you get one person who says, "I'm actually not using Java anymore. I'm on Python now. Please unsubscribe me." And the person didn't even say anything negative. They just said they don't care about Java anymore. They're doing Python. And that one comment will put me used to. Nowadays I ignore them, but used to make me completely depressed. I'm like, oh no, I must stop this. I must change everything and do something else, and just maybe start the Python specialist newsletter, just to So one has to be careful because it's all a mind thing. It's and keep on going, because you get this. You do well through a long-term relationship with your audience. And whenever I go to conferences, I meet people who've been on my newsletter for 20 years. So it's like, people have been there forever. They know more about me than my mother almost.
Mm-hmm. Yes, sure. There are also some comments from the audience. I think they are comments for some last things you were talking about. For example, from Bruno is here, feedback is such a hard thing to get.
Yeah, friends, yeah.
Friends,
and if you have a good friend,
feedback.
If you have a good friend, the friend will tell you things that will hurt you. That's a good friend.
Yes.
The stranger will butt you up and say, "Oh, you're the best," and "Oh, Heinz, the Java specialist, the most amazing," blah 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 blah. And then you go to Bruno and he said, "You could do this a bit differently, and actually stop talking about all this bullshit and actually talk about concurrency, because that's why we're here." You can be very direct like that.
Yes. And then Andres has got another comment. Passion is what is most contagious in a talk. If you talk with passion, you have more than 50% of the talk.
Yeah, totally agree.
It's also true. Yes.
I'm not so sure about that.
You're not sure?
No. I'm not so sure about that.
Do you want to comment about it?
I've seen very passionate people who are very passionate, very passionate, and no one has a clue what they're talking about because they're so passionate about their thing. They're like, this is amazing, it's amazing. And they're like, what the heck is he talking about?
Okay, so that's missing connecting to the audience.
I think no. Okay, so I'm going to change this. I'm going to say I don't agree to this one. I think that the thing which makes my courses good, because I do like live courses, in-person courses, is that when I do a course, when I do a talk, especially when I do a course, I go in there and my starting place is I love my audience, right? I love my audience, and my starting place is that the people who in my class, actually every single one of them is actually smarter than me, right? So they're all smarter than me. I love them. I love them because they are here to pay my bills. They're paying me to do something I actually enjoy doing, and so that's my starting point. Is one coming from appreciation that they're there with me, that they're listening to me, that they're paying me to speak, and so what I want to do is I want to get into their minds. I want to answer their question before they even ask the question. All right. So what I want to do is when somebody, what often happens to me, and this happens to me like very often, especially when I'm with people in the same room. Don't ask me how this works, but it works. All right. What happened to me is I'm going through my slides. I've got like a set a slide deck of stuff, going through it, and all of a sudden I get this thought on a particular slide, which I've seen 100 times before, and all of a sudden I get this question in my head about a very particular part of that slide, and I stop and I think about this, and then somebody puts up their hand and they ask that exact question. This happens often. This is not just once off, like lucky chance, and it's like very obscure things, like things that you'd never never imagine. And it's a bit like when I was a child. We used to have this game called Pictionary, and what you have to do is you have to draw a picture. You get like weird words like I don't know, passion. Take the word passion. They've got to draw passion. So how do you draw passion? You draw like people kissing or love or something, and you have to get the right word. And I'll never forget, I was playing with my brother. My brother and I, we were very in sync. Got to be in sync with other people, and we were very in sync. And and we were playing against other people. And my brother and I, we were killing them. We were absolutely killing them. And without cheating, there was no cheating going on. My brother, he had a piece of paper, he drew one line, just a single line, and I guessed the correct word, paddock. Just from one line, I guessed paddock. And the people sitting around like, how the hell do you do this? It's like, I don't know. I've got no idea. I know I can't read minds, otherwise I wouldn't have such problems in being married for 30 years, 31 years. I can't read minds, but it's just incredible when you're in sync with people. And this is sort of going to metaphysical level. I don't know how this works, so I can't teach you how to do this. But it's a matter of connecting with your audience where you actually know the question before it's being asked.
Oh, that's very interesting insight. When we say passion, might be not the passion for the solution or for the topic, but the passion for our audience, the passion to solve our audience issues, problems, maybe.
I think that's far more important. Because you're not doing the talk for yourself. You're not doing the talk to get to. At the end, that's what I said. I don't care if they score me 2 out of 5 for my talk. I don't care. Score me 1 out of 5. I don't care. I just won't go back. And I had this one experience. I went to one conference and they asked me to submit a talk, and I submitted a talk, and basically my abstract said something, and my talk was exactly about what was said in the abstract. But it was a very basic topic because it was a general conference. It wasn't just a Java performance conference, and we haven't even talked about concurrency performance yet. We still have to do that, otherwise you're going to give me like 0 out of 10 for this talk. But so when the people afterwards, they like complained, and they said, no, this was terrible talk, because we expected him to like really hardcore concurrency performance talk, but that wasn't the abstract. The abstract was a very basic talk, and that's what I did. But they didn't read the abstract. They just thought I'm going to talk about something, then they marked me badly. So I was like, okay, well, whatever. Skip that one next time. But it's connecting with your audience. It's connecting, and it's sort of metaphysical. It's not something that I don't know how to teach that. I think that most of the most of the speakers that are really good will do that to some extent. Like Josh Long, for example, he really connects with the people there. He does it through joking, self-deprecation and joking and telling funny stories about his dog or his whatever. He always has a great story, but he really connects with the people there. Bruno does that with his flag and all the kindness he comes with. But the other thing is that when you're doing a talk, you want to make people laugh as soon as possible in the talk. And I was in Athens once at a conference, and before the talk, I was talking to people, connecting with the audience. Again, it's all about connection. It's all about connecting with the people, and that's what's so important generally in life. To connect with people, being a connector. And so I stood up and I said something. I don't remember what it was, but I do know it wasn't funny. But I said just the right thing, and everybody started laughing. Just the right thing for that particular audience. And I mean, I live in Greece, but I don't live in Athens. So I still had to sort of do my homework, sort of work the crowd a bit beforehand to find out what would be the thing that would make them laugh. And so I started off, I said this, they all laughed. And afterwards I had lunch with one of the other speakers there. And she said to me, when you got up and you started with what you said, that wasn't funny. I said, no, it wasn't. And she said, why did they laugh? And I tried to explain. That was the right thing to say at that time. And that's something which you got to bring your magic. You got to develop yourself, your own character. And you need to think the way that the people think that you're speaking to. So you can't just do the same thing, the same jokes. It's got to be for that audience.
It's very directed for each one, right? I believe what Andres mentioned with passion would be kind of that first part you mentioned, that you love your audience and you love connecting to that audience. That's where the magic begins. And yes. I believe he didn't meant on what Bruno mentioned, and not on the passion about the subject itself, because it's became you blindly. I believe that was the point that you were mentioning. Exactly right. I'm blindly loving the subject, doesn't matter if that's good or not. I don't agree with that as well. But connecting with people, that's key for anyone. That's great.
Yes. We have got some questions from the audience. Maybe I can show the first one.
Dr. Heinz, would you agree that knowing how to build a good architecture, concurrency, caching strategy is much more important than the programming language?
And then he continues, in terms of performance.
Oh, okay. I'm not sure if that's a question or a statement. I'm not quite sure what question is being asked here, to be honest.
This one again?
Because this is not a question. It's a checkbox.
Okay.
So basically, architecture is important, performance important, concurrency is important. The actual programming language, you can. Okay, so let me rephrase the question. Okay, I'll rephrase the question, and that is, how much does a programming language as such affect the success of a project? Okay, and I would say that the programming language doesn't affect the project that much. It doesn't really matter if using Java or Python or Ruby or Scala or Scheme or whatever you want to use. It doesn't really matter that much, the actual programming language. What matters are the people that are using it. Because if you have good engineers, they'll build an amazing system with Visual Basic, you know. And if you have terrible people, they'll build a terrible system with Java, you know, a horrible legacy system with Java. So it really depends on what you have, what your team is capable of. So that's very important.
Amazing.
Yes. There are some other comments from him. Discussing so much about which language is faster, but don't know when to use a good caching strategy, good data structure, etc. So
Yeah. Well, you know, that whole discussion is interesting because when I first saw Java, I dismissed it as being very ugly. I saw it and it looked like the what's it called, AWT, applets with AWT. They look absolutely horrible, and they just looked like tickle TK. I thought, this is horrible. Nobody's ever going to use this. But back in the day when we started with Java, it was slow. The language was slow. But again, you got to ask yourself, and this is the same. Again, I'm going to rephrase the question. Performance of what? Performance of productivity? Performance of executing code? Transactions per second? What are we measuring? Because if we're measuring performance of the actual code, you know, that great. And data structures, people use basically array list and hash map. That's what they use. It's like maybe concurrent hash map, because hash map is not thread safe, but basically that's what people use, array list and hash map. And yeah, you can run into trouble if these things become larger and you start. And one example we had was one company I worked for. They had this one system, and it worked fine for 1,000 files per folder. It was great. 10,000 was already going a bit skewed and was a bit slow. But then the customer put 1 million files in the same folder, and you know, if you have a bit of, you know, and this gets down to complexity. You know, your big own notation. So, for example, if you take something like what did I see the other day? I saw something doing something silly with an array list. But let's make a list, new array list of integer, and we'll do. Let's fill it with something. Put in stream dot. No, let's make a thread. No, in stream is actually a good idea. In stream dot range 0 to million. Where is it? Let's put some underscores there. You can see it better. Dot for each list add. So put them all in there, and of course we could create that directly. I'm just going to do it this way now. And then we're going to do. What are we going to do? We're going to remove the middle element, right? So we're going to say while list dot is empty as false. We're going to say list dot remove list dot size divided by 2. Okay, so whilst it empty, let's start with less. Let's start with 10,000 elements and see how long it takes to do this. So we'll go and put time around that and run that, and we'll see how long it takes to do this. And for 10,000 elements, it takes 5 milliseconds. Okay, cool. That's not too bad. Let's make it 100,000. Bump it up a bit. Now it's 10 times larger, but it takes a lot more time. Let's make it 1 million. In fact, let's make it 200,000. So we need to double it. And now it goes 4 times slower. Double it again. And now we are What's this doing here? It's not supposed to be there. Weird. And now it's 8 times slower. So each time you double it, it goes 4 times slower. Right? So let's go back to 100,000, 250 milliseconds, or 230 milliseconds. And now, what do you think would happen if I removed it from a linked list instead? Because here we can do... So the reason why it's so slow is that every time you remove from the middle, you've got to copy all the old elements over by one slot. So you're continuously copying elements over and elements over. Whereas a linked list, if you remove from the middle, you can just like move the chain over and you're done. It's like super fast to remove. So how fast do you think it'll be to remove 100,000 from a linked list from the middle? Let's have some guesses. Give me some numbers. I'll write them down. So we'll put here array list, say 250 milliseconds. Linked list. Give me some numbers, please.
5 milliseconds.
Very good. Okay. Remember that this is quadratic, so it's not necessarily going to increase. It's not linear increase, right? Okay, but let's just keep 5 milliseconds. You know how that is. Because removing from the middle of a linked list should be constant time.
Okay. Andres says less than 1 millisecond.
Less than 1 millisecond.
Less than 1 millisecond. Okay, good. Yeah, that is. Jose, what do you say?
5 milliseconds.
Oh, you said the 5 milliseconds. Okay, so we've got the 5.
Yeah, I think we can run already. I'm getting anxious to see the results.
No, I want to have one more. Come on, we have at
one
least
more,
3.
One more. 2 milliseconds, Bruno said.
2. Okay, 2 milliseconds.
2 from Bruno. It took much longer.
Correct. Actually, about 5 seconds. Okay.
And the question is, why shouldn't this be faster than the array list?
Yeah, exactly. And I had this discussion, and I had this funny discussion here in the. So what people do is they send their people to Crete, and they say, you're going to go to Heinz, and you're going to go for a week to Heinz, and he's going to torture you with concurrency problems and performance problems, and so this one guy brought his whole team of programmers here, and you know what I was saying about people being smart. Now he's very smart, PhD computer science, and very smart guy. And he kept on saying that linked list is faster than array list for moving from the middle. And I'd say to him, no. And I'd say, no. And he'd say, yeah, no, but it's in a book. It's in a book. It's in the book. And he'd say, like, there's a book that he read by Kent Beck. And I know Kent Beck's also very smart. So I've got, like, smart guy in my room, and I'm going, like, oh, I don't want to go there. I know he's wrong, but I don't want to go into this because, you know, we've got a lot of material to cover. But he kept on hammering on this point, you know. You know what I said about people on the spectrum? He said, we don't give up. You know, but it's slower. Like, no. You're wrong about this. And then eventually I actually happened to have the book on my bookshelf. I've got this lovely bookshelf, and it was there. And I picked it up and I read it, and I said, right, the book's wrong. The book's simply wrong about this. Because you need to think about this. You want to now remove something from the middle. Well, if it's an array list, I can find the middle really easily. I just know that's the middle. But if it's a linked list, I first have to find the middle. Right? Mm-hmm. And I'm going to go from the beginning, 1, 2, 3, 4, 5 to go to the middle. So this over here, remove that in linked list is also linear. With Arridus, it's linear because it has to copy the elements over, but that's a bulk copy, so it's much faster than iterating over. So you'll see this. So for example, I make this 10,000 with linked list. It's 64 milliseconds. 20,000, you'll see it eventually ending up being 4 times slower. Okay, that's not quite yet, but probably the next time. 40,000 will probably be 800 milliseconds. Yep. Do it again, double. Would again be now 1600 milliseconds. Oh, it's actually worse. Yeah. So you sometimes end up being worse than double. But usually once you get to this bump, which normally has to do with caches, because you're talking about caching strategies, then you end up again being quadratic after that. So now I'm going to guess it's going to be about 12 seconds. My guess. Yep, there you go, 12 seconds. So it's very important to know data structures. It really is. And yeah, I've seen some very, very strange code with that. Most of the time you're okay because the data structures don't get that big. But if they get large, you can run into problems. I found a bunch of mistakes in Java. I don't know if I can show one of them to you.
So knowing
let me show
about
you a bug. Sorry?
knowing about data structures is much more important than the difference between the language itself, right, Heinz? Because you will have these data structures in almost any language.
Yeah. Well, it's understanding how things connect and what the implications are for memory access and so on. So yes, you could have a similar type of data structure anyway. If it's a linked structure, it's a certain thing and so on. So let me, because I wanted to talk about concurrency. So let me show you something which I think was quite funny. So I wanted to make a very, 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 very large linked blocking deck. Okay.
Nice class name.
Yeah, it's very large. It's a very, 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 very large linked blocking deck. Okay. And so how do you make a very large linked blocking deck? Well, what you're going to do is you're going to, first of all, make a normal linked blocking deck equals new linked blocking deck without anything inside, just empty. Let's make it integer. Okay. And then we're going to fill it with objects. And then, in fact, we're going to pass in a collection of objects. Okay, now, so we're going to say lbd dot add all new extremely humongously large collection. And we're going to make it 2000 to let's make it integer dot let's try how to do this 1L left 32. That's very large. Okay, that's a very part. Let's make it this like this. That's a very large number. Okay. Sorry. All right. So we need to make this, and then what we're going to do is we're going to say print out lbd.size. So this now is we're going to make a class, an inner class over here. It will be a static inner class. That's going to be the size. Okay, it's a collection. And what this collection is going to do is we're going to have a field for the size. Okay. we're going to override, in fact, this is going to be an abstract collection. So we don't have to implement all the methods. So it extends abstract collection. And we're going to implement the methods that we need, which are iterator and size. We don't need to have, and the size is actually going to be if size is bigger than integer dot max value, return max value, otherwise return size downcast to an int, which is a correct definition of size, by the way. That's actually how you're supposed to do size. All right, so now I'm going to make an iterator, return new, let's put here long pos equals 0. And no, so it's got to go somewhere else. So we're going to say return new integer with a private position equals 0. Now, I've written code like this before, but just once or twice. So if we get this wrong, help me. Has next is going to say return pos is less than size. Okay. Return an integer next is I'm not going to construct any object. I'm just going to return number 42. If pos is bigger than size, I'm going to throw an exception. Otherwise, I'm going to say pos plus plus and return 42. Like that. So it's always the same number. I'm not going to make objects that way. So this allows me to make an extremely large collection of items, always the number 42 coming back, of basically any size I want, any long I want. And the iterator will just keep on running with it. So for example, if I did the following, let me show you quickly. Let's say print out new extremely humongous thing of 10 like that. Okay. And that's it. And when you run that, you'll see just a collection of 42 times 10. Okay. Because the other methods inside abstract collection are all using size and iterator and size. That's all you need. Now this is a read-only collection. You can't change it, obviously. It doesn't actually have any values. But this allows us to make a very large, extremely large thing. So what we're going to do now, we're going to run this. So this is now, it's going to take a while, and I'm going to run it. I need to give it a lot of memory. Now, normally when I start off, it's going to give, by default, the amount of memory is going to be the max memory of the machine, the physical memory divided by 4 is the default. So if you say runtime.get runtime.max memory, right? And that's going to be in bytes, I think. Yeah, that's in bytes. So I've got a 96 gigabyte machine. So we're going to say 96 divided by 4 is 24 gigabytes. So 24 gigabytes by default. And in Java, when you start off your virtual machine, if you have less than 32 gigabytes of memory, then it uses compressed OOPS. So each object uses less memory in space. But if you have more than 32 gigabytes, then each object uses more memory. Right. So basically, what we're saying is that when we make an extremely humongously large collection, or if we make a linked blocking queue with all these elements inside, then it's going to make an array. Not an array. It's going to make a linked list of those objects, and these objects will take more memory once you exceed 32 gigabytes. So it's like if you're just below 32 gigabytes, you actually use a lot less memory for almost the same amount of objects than if you go over 32 gigabytes. Right. So my point is that we're going to need more because this is big. This is very big. So I'm going to say minus mx. Let's make it 90 gigabytes, and I hope my machine won't crash. If it crashes, I'll be back. All right, don't go away. And we'll use the. Let's use plus use parallel GC. Very good. Let's run that. So now you can see that it's now allocated 90 gigabytes of memory. And it's going to run for a while. It's not a quick run. Because now what it's doing is it's taking all these objects and allocating them. So what we can do, just to keep us a bit happy, we're going to say if pos percentage 100 million equals 0, print out pos, just so we can see that something's happening. Otherwise, we might have an infinite loop somewhere in our code and we wait forever for this to finish. Right, so it's counting up. It's 400 million. That's taking a while. Now, one thing I'm worried about is that I'm running a lot of stuff on this machine. Okay, it's coming on again. So there obviously are GC pauses happening here. So let me try this again. I'm going to use a different GC for this because this is taking a bit of a long time. Let's stop this. I think the GC is... okay, so we run this. Let me just use a normal G1 GC, not the parallel GC, and see if that copes better. Because the G1 GC is supposed to scale better for larger heaps. And we can also try ZGC. I'm not sure if that's going to be better or worse. Here we can see that it seems to not have these extremely long pauses for the GC. So let's just stick with this one, G1 GC.
With the parallel, it seems to come in bulks, right? And this one is just coming one after other.
Yeah, exactly. The G1 is supposed to cope better with larger heaps, and this is definitely a larger heap. So 1 billion, 1 billion 2, 1.1 billion.
Heinz, while is running the program, may I ask you a question about the last exercise that you showed? You showed
Sure.
the linked list, and like the linked list, it took more time because it will execute the ON, right, for remove the element.
No, not to, yeah. Well, the remove is ON because you have to find the position first.
Yes, yes. So it iterate like over all the elements, not all the elements because we are removed from the middle, right?
Yeah.
That's kind of. And my question is because it's like you said, it's not very clear that linked list does that. So it's ON.
No, it's very clear. If you know how it works, it's very clear.
Yeah,
It's completely obvious. Everybody would know that.
It was not maybe for us at the beginning when you show. But my question is, we do have this kind of operation like get in the linked list that it's ON, but we do not have get for hash set or any set. My question is, why do you do not have this kind of operations in a set that you take ON also? Why do you not have this kind of operations for set, but we have for linked list?
Good question. Very good question. Very good question, actually, because you within the set, you see, it's a sequence collection. It's basically going in a certain sequence, but the set is generally not sequenced. So, but a set, there's no way of getting an element that's in there. You can only remove it or say, does it contain it? Right?
Yeah.
But you can't. But you can't. You can't find. You can't get an element from a set. So there you'd have to use a map and have the key and the value being the same if you want to do something like that.
Yes, if you wanna get the element in a set, we need to go over all the elements, right? And then
Yeah, exactly. So if you want to get an element from a set, you make it a map, and then you have the key and the value being the same.
which is the same as the linked list, right? The linked list will do the same operation when we try to get an element. If you go over all the elements, right?
No. With the link, with the hash map.
With the linked list, not the hash map. The linked list will do the same, right? It will go over all the elements and get the element, or remove as you have done.
Yeah, I hear what you're saying. So basically, let's go back to that demo quickly, and then I'll look at the results. This was a demo here, and the demo was basically if you wanted to do something like this with a linked hash set. Okay. Now it would be. This is tricky because actually there's a remove, but the remove is the wrong remove. It's trying to remove an item, not a positional thing. So let me change this to being not an integer. Let's change it to being a string. So I'll change it to strings. And we're going to say map to object. I plus I dot reach list add. Okay. So so it's a linked hash set remove is now trying to remove the item. Okay. Whereas before, if you make this a list, remove is removing the positions, index. Okay. So basically here, I would say if list dot is not empty, throw a new assertion error. Okay. List should be empty. List.size. So you'll see that for the no, rang the wrong code. So here you can see it's fine. If I take a linked hash set with strings inside. Oh, sorry, that was wrong. Let's do that again. Linked hash set is going to come back as never ending, actually, because list empty is never, this never ends because it's not actually removing the elements. You're trying to remove integers, but there are strings inside. So this will never end. So actually this will never end either. So so what you can do here is you could then say our list is not empty. I could say int target item equals list dot size divided by 2. And I could say, I could iterate through, I could say for I iterate over the list, and I could say if we have to do a counter as well, int index equals naught. If index plus plus is equal to the target item, then I can say list.remove s. Okay. So this would work for a set now, if it's a set, not for a list. Okay. So, or what I can actually do is this. I can say if list dot instance of set, then do it this way. Else if list instance of, well, I'll just else do it that way. But the queue also doesn't have an index as well. So let's just say else if list instance of list, we'll remove it this way. Okay, and then I need to be careful because, yeah, okay, so that should work now. Let's run this, and we should see that it, why does it do that? Oh, it should break out of there. So once we have removed it, we need to break out of this. So we need to say list remove.
I think this is the first time I saw someone doing having code with label. It's not very common, right?
No, but it works now. You see, it works. So the point is, this works, and the performance isn't that bad. I mean, it's not that bad. It's similar to the, what is it like? Now it should actually work with the linked list as well. It's a bit worse than linked list in terms of performance, because it still has to find the element afterwards, and much worse than the array list. But it does.
Got it. Yeah, if you have used linked list and used the index instead of the object, probably to have a much better result, right?
No, that's what we're doing.
The linked list, and try to remove using the index instead of the object.
Exactly the same. It's exactly the same, because you first have to find your position, right?
But the linked list with the index, it does not find the element by the index and does not need to go over all the elements.
Of course it does.
Oh, okay. I thought it not needed.
It's not a random access list. You see, the array list, for example, implements random access, which means you can access any element in the random access collection directly. With the linked list, you need to iterate to find the right place.
Okay, got it.
This is very basic computer science 101, and it's extremely uncommon knowledge. So you're in good company. Hardly anybody knows this. Do you know how many people I've asked? I mean, I've asked at lots of conferences, I've asked this question: what is faster, removing from the middle of a linked list or an array list? And 99.9% of people say the array list is slower than the linked list. But they don't think that you first have to find the position to define the middle. When you add that in, a linked list uses up more memory, then you end up with a problem, right?
Cool.
All right, I'm going to quickly do
Learn
something.
a lot here, yeah.
Sorry?
Yep, learning a lot here. And I'm curious about the last exercise.
Very large.
Large.
Yeah, that's very, 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 very large. But before we continue, I'm going to quickly just do something because, so here's the thing. I went to a fairly good university, fairly good being like the best in Africa, okay? But it doesn't mean much. I mean, Africa doesn't have the best educational system, and it's the best in Africa, but it doesn't compare to like a British university or German or Swiss, or I don't know where Brazil stands, but it might be as good or as Brazilians, but it's actually better than the university in Vienna. So, but we spent a fair amount of time with data structures, also using them and writing our own in our first year. and a lot of other things we learned, like recursion. I was very good at recursion back in the day. And then when I taught my very first course on programming, I had a bunch of COBOL programmers learning Java, and they'd never done recursion before, never. And so I said to them, write this recursive function that prints out all the class names back to object, and they had no idea what that even was. They'd never done this before, and so I said, well, it's just like mathematical induction. And I just saw the sea of blank faces that never heard of induction before. And I said, if you want to prove, for example, I don't know, the factor or whatever algorithm you want to prove, you just prove it for 1 and then 2, and then you say n plus 1, and you get this proof. And they go like, what the hell is this guy talking about? They didn't have a clue what I was talking about. And then one of my students had a master's in engineering, and he said to me, that COBOL doesn't have recursion. I had no idea about that. So again, this is, knowing your audience and actually not just taking stuff for granted. So what I'm going to do, just to give you something, because I see that this actually might be helpful. It might be helpful. So I'm going to give you a gift. It's a course I wrote a long time ago on data structures, and I'm going to give you a gift of this. Let me just put here coupon code, and I'll leave the coupon available for like a week, right? So if people, because you're obviously going to publish this, and so this is going to be, I'll call it Schiller, so I know where it's from, and we'll just quickly set this up for you. And 225. Let's make it to October the 1st. October the 1st. That's good. That's 1 week, roughly 1 week. And okay, so save that. I'm going to give this to you, and you can post this somewhere. So what I'll do, I'm going to just give you quickly what is this podcast called again?
Yeah,
Sorry?
out of the box
Out of the
developer.
box developer.
Out of the box. Okay, that sounds good. Sounds easy enough. So I'll put the long one
Yeah,
there.
guys, we are going to have a gift from Heinz.
Yeah.
People are excited here in the chat.
Out of box. I'll call it. Okay, I can't get. I'll just call it Scylla. That's easier. Because it was also not available. Scylla not available either. Oh, come on, now this is ridiculous. Let's call it data. Okay, I'll just post the link directly. And is there a place I can send a chat thing to? How do I send a chat message? I'll send it to you on WhatsApp.
Yep.
And maybe you can post it.
Sure.
And you can put it on the in the description for the video as well if you want.
Excellent.
And but it's only going to be valid for a week. After that, it's going to expire. But once you've got it, it's available forever.
Mm-hmm.
And this is a data structures course, which and I've got a quiz in there, and the quiz is actually not that easy. The quiz is all sorts of weird questions to do with data structures, and if you get 100% for that quiz, I'll be very, very impressed and surprised, because I don't think I would get 100% either on the quiz, even though I wrote it. So that's a little gift for you.
If you get 100% on the quiz, message that to Heinz.
No, if you got 100%, you made a mistake. That's my rule. That's my rule.
Oh my! And guys, I also believe that's a great content for studying, since many companies requires you to prove your data structures knowledge in interviews these days.
Oh, no.
You don't think so?
You know what's going to happen, right? If you do my course, you're going to go to the job interview, and they're going to ask you a very obscure question. Like, they're going to ask you the question, what is faster, removing from the middle of a linked list or the middle of an array list? And you're going to answer the correct answer, which is it's actually faster to remove from the middle of an array list, and you're going to get marked wrong.
I see. You need to answer what they want to hear.
You have to be really smart about this. You have to say, you have to explain why. So let's say I go for the job interview and they say, Heinz, what is faster, removing from the middle of an array list or linked list? I would say to them, the answer you're probably looking for is that it's faster to remove from the middle of a linked list because you can simply point the link from the previous to the next to previous, and you're done. But the real answer is it's faster to move from the middle of an array list because even though you've got to copy all the remaining elements over by one element, that is still faster than finding the correct position inside the list. And what's going to happen is your interviewer is going to be like, huh? What? And you might get the job. You might also not get the job. I don't know. But this is a real problem. You know, I wrote the Java, the Sun certified Java programmer for Java 1.1. I wrote that exam, and I think I also wrote another exam for 1.3, 1.4, and then I stopped. I got bored of those things, and I didn't score 100% for either of them. But I got to one question, and there was no correct answer for the question. It was a concurrency question. And they'd messed up. The correct answer was the code wouldn't compile, right? But they didn't have that as an option. So I sort of didn't quite know what to do. Eventually, I answered what I thought the answer was that they wanted me to answer. But I might have gotten that wrong as well. And so I wrote to my newsletter about that. I said, if you find a question that has no correct answer, hit your head on the keyboard or the table. And somebody from Sun actually wrote to me and they're saying, "What are you talking about? Wrong questions." And of course, I didn't have a picture of the question, but I sort of described it to him, and he found the question, and it was wrong, and they removed it from the test. That's what I'm saying. If you get everything right, you're probably going to be wrong. So let me show you this quickly. This was the very, 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 very large link blocking deck, and we ran the code, and here's what the size is at the end. -2 billion. Okay. So I discovered this a few months ago because I was doing a course. I was preparing a course, and this one I will not give you for free. This one you have to buy if you want it. But I'll give you a link to it because it's a great course. So this is a course which I wrote, and it's a course on specifically the Q and link blocking deck, how they work. So I'll give you the link, but not a free one. This, if you want it, you have to buy it. And what I did was I actually looked at link blocking Q and link blocking deck like no one's looked at this for ages. It's like incredible detail, like really, really detailed. And I found 5 bugs in the link blocking deck. This was one of them. And I fixed it, and I submitted the fix. So if you now take, for example, the project, you take Java 26, and you run with the Java 26, and it's not been released yet, it's still the beta, but my fix is in Java 26. So I need to run this one. This is the very, very, very large. We run this again. So if you run Java 26, oh, it's a problem here. Sorry, I need to put this down here. Okay. So we'll do this from the command line. For some reason, it doesn't want to do it. I have to refresh everything. I don't want to do that. So let's just do it in the command line. Java 26. And source main Java. So it's Java minus X MX 90G minus XMS 90G, and then it's dum Solar and very, very, very large database. So is this now running just with the G1 GC? Oh, actually, you know what I want to try out just whilst we're doing this? I want to see, come on, stop this. I want to see time with it and see how much time this all takes. So it's busy making this, trying to create this very large structure, and it will prevent me from actually constructing such a large link blocking deck. So once we get to 2.1 billion, it's going to crash. It's obviously a big workload, and what I want to do after this is to run this with ZGC and see if we get different results with Java 26.
Well, while we wait here, I think it's worth saying hello to Mary, Mary Grigolski. She is also on the chat.
Really?
And said hello to Heinz.
Hi, Mary.
Hi, Mary. Good to have you here.
Yeah, Mary came to J-Crete last year with Mary and Maria. It was really great having her here.
Cool stuff.
Okay, so what happens now is if it picks up that you've done something really idiotic like this, it will then go and default back to adding it one by one until it runs out of space. So internally, what happened before is it would create this whole collection and then attach it to the end of your existing link blocking deck rather than doing it one by one. But what it does now is if it detects that it's actually too big, like it detected it over here, then it's going to do it again, but add the elements one at a time. And so that's why it's counting it again. That's why it's another counting. So it takes a bit longer. Almost done. So almost like what I'm doing is I'm punishing the people who are doing stupid things. Like, you're going to wait twice as long to see an error.
But it will continue adding in the end, or
no, it'll crash. In the end, it'll crash.
It'll crash.
It'll get out of memory error or something like that. Illegal state exception. I think it's out of memory error. No, actually, I'm not sure. I'm not sure what the error is, but it's whatever error you're supposed to have in the circumstance.
Yeah,
might be illegal state.
That's unexpected from the very beginning.
What's really difficult with these bugs is that you need to keep the codes to still be correct. So you can't make it incorrect.
Oh, yeah.
So that's right. Illegal state exception deck is full. Okay. So that was with Java 26. So 12 minutes of user time. And if you do the same thing with ZGC,
Oh, much faster.
it's not just a bit faster, it's like massively faster. Let's see if it stays faster.
And what this ZGC stands for is for garbage collector as well?
Yeah, that's the new garbage collector. They want to make this the default.
Oh, so that's on Java 26?
No, it's been around for a while. I think it's Java 17 it's been ZGC.
Oh.
But this is now this has the potential to have also a generational garbage collector. But it seems to be struggling here. Yeah, it's stuck. So it's, it's probably gotten to a stage where I think the problem is I don't have enough memory in my machine to run this experiment. I actually need a bigger machine because the problem is that if you get a situation where the GC can't keep up, it's going to have to do a full GC, and that can be very, very slow. So you need to have more head space for something like ZGC to operate properly. And I mean, this can sync your system. Like you go, oh, great, ZGC is so much faster. And we were all like, yeah, let's use that always in future. But when it goes bad, it can go bad spectacular, as we can see now. Let's see if it ever finishes. And if you look at top, see Java's pretty busy. It's actually not that busy.
91 gigabytes memory.
Yeah, but I pre-allocated that, so that's
pre-allocated. Okay.
yeah. I set max and initial to 19.
Oh yeah.
But it's still stuck.
Oh.
So when things go bad, they go bad. So use with caution. And I don't know if this will ever even finish during this course, during this chat. So I'll just let this run. I'll hide it away so you don't see it. Any other questions? We've been going for 1.5 hours. And Sheila's from Switzerland, so if she says 1 hour, it's like 1 hour, or you get shot. Get out! Get out!
No. It's such a good conversation, so I just don't want to stop it.
Well, I mean, as I said at the beginning, if this is crap, it's your fault. You are asking really great questions. So whilst it's running, ask me some questions about anything to do with Java, concurrency, programming.
Yes, there have been questions. There have been a lot of comments. Okay. And before those comments,
but I can't see the comments for some reason. I don't know where to see them.
You don't see?
No, I don't know where the comments are. There the comments are.
They're on the live chat tab.
Okay. Oh, there's so many.
I just need to find it. Yes, here it is. There was another question from Andres. That's what I was looking for.
How much do you think structural concurrency will impact readability of Java concurrency? So that's a good question, actually. Very good question. Yeah, I remember, many years ago when computable futures came out, and I was like trying to figure out how the stuff goes. You look at the samples they give you, and you go like, how does this stuff work? And so eventually I figured it out, and I had this thing that I was doing with computable future, and I had it. I was very proud of the fact that I managed to get it working, because I suggested one of my friends to use that as an example in an article he was writing, and he did, and he got it completely wrong. So I then managed to actually get it working, and I was like so proud of myself. I was like, yeah, they got this working, fantastic. And I did a course at this company in somewhere in Europe, and one of the students was looking at my code, and he's like, there's a mistake. And I'm going like, what? There's a mistake? What do you mean there's a mistake? And he's like, you actually, you should do this differently. The one of the threads there is actually waiting unnecessarily. You should do it do it a different way, and then it'll work. And I'm going like, what are you talking about? And then I checked, and he was right. It was actually a mistake in my code, and it could have been done much better, one less thread, and better throughput. And my point is that using computable futures, I always found very difficult, because what you're doing is you're basically building up an abstract syntax tree by hand. That's what that's all about. It still hasn't gone forward. It's completely stuck. It's like a 1 hour GC. I'll let this run overnight. I'll let you know how it continues, if it finishes. But unless I get too bored, then I'll stop it. But basically, what happened is that I couldn't get my head around it, and I have managed to do some good algorithms with it, but the problem is that it's just very hard to get it right. And structured concurrency makes it much easier to specify complex problems. So yeah, I think in terms of complex workflows, structured concurrency is definitely the way to go. There's not a question about that. I've got another course that I'm also not going to give you, because I can't give you away all my courses, but I'll give you a link to it. And that one is about virtual threads. In fact, you know what? There's actually a bundle. That's actually a much better option, because this has a whole bunch of courses, including the ones that include some other ones. But this is a great bundle. If you want to treat yourself at some point, that's what you should be getting. How do I open the chat? Make the open chat. How do I add something to the chat? Oh, I need to log in. That's why I can't chat. So I'll just send the link to Shodan so I can post it. So use that link instead of the other link is also good. Leave the other link as well. But this one, I'll give you another link. But basically, what happens is that you what was I talking about now? Yes, the structured concurrency. I'll start with like basic, doing it without threads, then with threads, then with computable future, then with structured concurrency, and it's so much easier. It's like night and day. So I think that if you're going to write complex workflows, that's what it's for. Structured concurrency is going to make our life a lot easier.
That's amazing. And Heinz, I would like to ask you a question. It's kind of a polemic question. For us that are in programming world for so long, so many years, it's kind of natural to learn and to understand how things works to build systems. But in the last years, we have the rise of AI everywhere, AI here, AI assistants, AI agents. How do you see the understanding of concurrency, of the language, of data structures in this world where AI is this hot subject, hot topic? Do you see that as a hype, or do you see that as something that is more needed than ever? How do you see that?
So I had to go to see a doctor a few months ago, and I had an issue, and I went to ChatGPT, and I typed in my symptoms. I said, "This is my problem," and then I knew what the problem was, because ChatGPT told me what my problem was, and then I went to the doctor, a doctor specialist in that particular part of the body, and he checked me out, and he asked my questions and so on, and he said to me, "This is your problem." Okay. And it wasn't at all what ChatGPT said. Okay. To me, it sounded perfectly legitimate, because it's what ChatGPT said. Right? And it's very convincing. It sounded like the right answer. The doctor said, "No, if that was your problem, you would be you'd be living on morphine. You would not be living without morphine. You'd be like permanently on morphine, you know. So the doctor sort of knows that he sort of knows, because he's studied and he's seen more case studies, and he knows sort of the strength of symptoms, what exactly your problem is. Probably not, right? It's probably not that I thought it was. And so this is a very common problem. In fact, in England, I don't know about other countries, but in the UK, doctors are not allowed to consult ChatGPT about medical issues. They're not allowed to. So if you go to the doctor and whilst you talk to them, they type with the ChatGPT, this person has got like, I don't know, a sore head all the time, and it's tingling in his left ear, and his right nostril is oozing blood. They can't type that into ChatGPT and then say, what do you think this is? They're not allowed to. It's unethical. Okay. And the reason's kind of obvious. You know, we've studied extensively to get where we are with software development. And so we actually have a certain skill set of being able to take customer requirements and sort of trying to figure out what the heck they're trying to actually ask us to do and convert that to working code. We're able to, it just did another 2 data points, 3 million and 4 million. So it's moving very, very slowly. It's like really struggling along. So what I'm saying is that we basically have a very we're able to manage this quite well as programmers, because we are professional programmers. But AI might get it right, or it might get it horribly wrong, like really, really badly wrong. So, and it's the same. I think that if people just do vibe coding, we have to be very careful, because we can end up with incredibly dangerous bugs, mistakes, code that's just horrendous and hard to work with. And it's kind of weird that a medical doctor is forbidden from using ChatGPT to check patients' symptoms. And I saw, if I'd gone down that road of what I thought was the problem, that would have been problematic. Would have been problematic. But the thing is that the doctor has a much broader experience. They've got a lot of studying, and so if I compare those two domains, it almost should be considered unethical for programmers to simply write their code with ChatGPT. Now, I have used it myself. Obviously I've written code with it. Everybody has by now. But we have to be very, very careful. Another thing which is interesting about that is that we had a discussion on the Java Champion user group, and they've discovered there's this class action suit against who's it now? Bruno, you might remember who it is against. But there's a class action suit where one of the AIs has just gone and basically sucked in all the textbooks. And because of all the textbooks, you end up having a whole bunch of copyrighted material in there, which are not properly sourced, so you don't really know who you're copying there. So now there's a class action suit where this AI company has to now pay out all the authors, thousands per book, which is still not enough to compensate for them stealing all their work. But what worries me is, let's say, for example, I want to write another course. I want to write a course about, I don't know, Spring AI. It wasn't Google. I don't remember who it was, but it was one of the AI companies. Let me see if I can find that.
Yeah, I'm not sure if it was Entropic.
That's the one. That's the one.
Entropic.
Yeah, I think that's the one. And yeah, so the point is, let's say I want to write a new course. Let's say I want to write a course on Spring AI. So what I do is I go and I ask suggestions from from ChatGPT or that other AI that has all these textbooks. Give me some code examples for this, and it says, oh, there's a good example, there's a good example, there's a good example. But these are all from like somebody else's book that he's published, and I'm using copyrighted material for my course. And some other course leaks, and they sue me for copyright infringement for just stealing their material. I didn't even know that. I'm just using the ChatGPT or whatever I'm using. So it should be considered unethical to write production code with that. But yeah, as an assistant, I can see how that can be useful. Sometimes.
To help you maybe develop and to know how to do things on another language or different syntax, or even discover more features from that language, like an assistant. I totally agree on that question.
Exactly. So I've got a very good. I have a very good friend who's like a super clever guy, super clever. Right? And you can ask him anything in the world. Like it doesn't matter. You can ask him about wildflowers, and he always has an answer. Like he always has an answer. It's annoying because he always has an answer, and he catches answer not always correct. So it's like ChatGPT. Basically, there's always an answer. So you take the answer and then you try it out. No, that's actually the wrong answer. So do something else. Okay, maybe that'll work. Let me quickly show you this here. So we have the.
Oh, we got the result in the end.
We did, yeah. Eventually it finished. So the first one was real time was 3 minutes. System time was 6 minutes. So that's a lot of system time, but there's a lot of course, GC going on. It's all GC here. User time, 12 minutes. So it took 3 minutes to run, 12 minutes of user time, 6 minutes of system time. So 18 and a half minutes of CPU time used up, and 3 minutes, 44 seconds of wall clock time. Okay. This one down here with ZGC took 12 minutes, 50 seconds. So 13 minutes. That's 4 times as long, roughly 4 times as long to finish. User time was 10 minutes. So before user time was 11 minutes. 12 minutes. So actually user time is less, but the system time is a lot more. And it looks like, if you look at this, it actually looks like it was running basically not very parallel. So ZGC doesn't look like it's very parallel for this particular use case. And I think we had some very long GCs, like 5-minute GC and stuff like that.
Okay, so we have to take lots of care about the garbage collector as well. Which one we're gonna be using for which kind of problem we are running, right?
Yeah, you got to be careful, because if this happens in production and you have 5 minutes of outage, that can be a real problem.
Excellent.
The ZGC looked faster at the beginning, but in the end it took longer.
Yeah, exactly. So you always have to look at the extremities, not just the best case scenario. All right, I think we should wrap this up. It's been almost 2 hours.
Well, that has been amazing. We learned a lot about
It's been
from
fun for me too.
Concurrency.
And as I said, this is your doing. You did it. You made it great. So thanks for your great questions.
Amazing. Thanks for being with us today, Heinz, for everything you have showed us. For our audience that are together with us here for almost 2 hours, it was a pleasure to meet you here today.
Yes.
Yeah. Go ahead, Sheila.
Absolutely. Thank you very much, Heinz, for this conversation. So sharing your wisdom. I learned a lot, and I need to review the video once again. Yes.
Heinz's smoke and mirrors.
Excellent. I also get the course video here and subscribe it. And so yep.
And if you're not on my newsletter, you really owe it to yourself. It's javaspecialists.eu, and you can sign up on there. It's free.
Excellent.
Once a month.
Excellent.
Mhm.
So thanks a lot. It was great lessons here. I see lots of new things I never seen before running through this live coding. So very interesting insights. Thanks a lot.
Yeah, I can say the same words from my colleagues. Thanks a lot. It was very useful. Thanks everyone from the audience too.
Yeah.
And yeah, we have 2 Java champions on the chat. So yeah, it was really fun.
And a whole bunch of future Java champions. We've got like 3 Java champions and another 12 future Java champions.
Yeah, amazing.
Okay.
Great.
So here I'm not sure if Chila mentioned it.
Yes.
We got wrap up here, and then in the end we say a few minutes just to on the backstage, so we can talk a little bit. Are you fine with that, Heinz?
I'm gonna sign off after this. I've got some
Okay.
other things I need to attend to.
Thanks.
Okay.
Thanks,
Thank
everyone.
you so much.
Right.
And for those of you that are watching us, check to get the free gift from Heinz here. It's on the links on the here on the chat. He just gave for everyone that is watching us his data structures course, and also share some other courses. His Java concurrency bundle courses. Check out that, and that's it. Thanks again, Heinz, and thanks for everyone that is watching us.
Thank you.
Bye-bye.
Bye.
Take care. Bye bye.